Hello, everyone. Welcome back to another episode of Agentic AI, the future of intelligent systems. Today's episode goes into the architectural foundations that matter even more as agentic artificial intelligence becomes part of everyday systems. Because the moment artificial intelligence starts acting, deciding, planning, rewriting workflows, and connecting across tools, the architecture underneath becomes the real story, not the model, not the prompt, not the agent. The architecture, modern architecture is being rewritten in real time. Code is generated instantly, agents trigger chains of actions, and organizations expect faster delivery with fewer moving parts. Yet somehow, with more autonomy, more reasoning, more orchestration, and more responsibility, in this world, architecture becomes a design philosophy, not a diagram. And that philosophy rests on 10 principles, not as a list, but as the mindset required to build systems that survive agentic AI speed, unpredictability, and scale. It begins with modularity. Agentic systems behave like living organisms, evolving, branching, swapping tools, changing workflows. Modularity makes sure each agent, each tool, each model, and each workflow sits inside a clean boundary. The planner can evolve without breaking the executor. A reasoning loop can improve without affecting the tool chain. A memory store can expand without polluting the rest of the system. Without modularity, agents create accidental coupling. You update one part, and five other behaviors break silently. Modularity gives agents space to evolve without chaos. Then comes simplicity. In agentic systems, complexity grows on its own. You add a planner, it spawns nested steps. You add a tool, it triggers three more paths. You add memory, it starts storing everything. Simplicity means designing the system so each agent's behavior is predictable. Clean interfaces, no hidden logic, no magic steps, no unnecessary layers that confuse both developers and agents. When simplicity is ignored, reasoning becomes guesswork, debugging becomes archaeology, and even the agent struggles to understand the environment it operates in. Scalability now has a new meaning. Agentic AI doesn't just scale by volume, it scales by variability. New tools, new models, new workflows, new channels, new integration surfaces, new forms of user behavior. When a system is not architected for variability, one new agent workflow becomes an architecture rewrite. Modern scalability means a system can absorb new agent actions, new orchestration patterns, and new decision pathways without redesign. The system must stretch, adapt, and evolve just as quickly as the agents driving it. Reusability becomes the multiplier. Agentic AI thrives on patterns, reusable prompts, reusable tool contracts, reusable workflows, reusable memory schemas, reusable domain models. Without reusability, every agent ends up reinventing the same solution. A new prompt pattern for every task, a new tool wrapper for every workflow, a new memory structure for every agent. Reuse keeps behavior consistent and reduces training overhead. In agentic systems, reuse doesn't just save time, it prevents entropy. Maintainability takes a new dimension. AI generated code is fast, but it is also fragile. Agent workflows update themselves, tool contracts drift, and reasoning paths evolve on their own. Maintainability means designing guardrails so the system remains understandable even when agents modify or generate components. If the architecture does not enforce boundaries, AI created components become legacy immediately, tightly coupled, duplicated, and impossible to refine later. Maintainability ensures that both humans and agents can understand, extend, and correct the system as it grows. Security transforms dramatically. in an agentic world. Agents don't just read data, they act. They trigger tools, modify states, run workflows, move information, and sometimes operate unsupervised. Security must become embedded into architecture, identity driven action control, zero trust tool boundaries, encrypted pathways, behavior validation for agents, provenance for every tool invocation, and automated scanning for prompts, memory, and actions. Without these foundations, agent actions become an unpredictable security surface. Sustainability becomes essential because agentic systems are compute heavy by design. Planning loops, reflection cycles, memory queries, tool calls, multimodal orchestration, each contributes to hidden energy and cost. Sustainable architecture means designing lean agent flows, lightweight tools, efficient retrieval, right size prompts, and local execution where possible. If sustainability is ignored, the system becomes expensive to run, slow to scale, and environmentally unsustainable. Efficiency is the new intelligence. Economical architecture sits right beside it because every agent action is a cost, every tool call, every reasoning step, every memory search, every retry all carry a compute signature. Economical design means controlling recursion, limiting unnecessary reasoning depth, reducing idle tool calls, minimizing data movement, and selecting the right model for the right task. Without this principle, agentic systems quietly burn budget faster than they create value. Ethical architecture becomes unavoidable when agents act autonomously. They recommend actions, influence choices, summarize sensitive data, and sometimes even make decisions. Ethical design ensures fairness, transparency, clarity of purpose, consent, and protection from unintended manipulation. It ensures agents do not cross social or cultural boundaries and that their suggestions stay aligned with human intent. Without ethical grounding, agent behavior becomes unpredictable and trust collapses. And finally, responsible architecture, the broadest lens of all. Agentic artificial intelligence does not just optimize tasks, it shapes decisions, behaviors, and outcomes. Responsible architecture acknowledges this influence and designs for long term impact, accountability, user safety, societal awareness, environmental responsibility, and operational transparency. Without responsibility, agentic systems scale faster than organizations can control their consequences. And that brings us to the closing thought. Artificial intelligence can generate tasks, plan steps, trigger tools, write code, and operate autonomously, but it still does not understand boundaries, ethics, sustainability, maintainability, or long term consequences. Those remain architectural responsibilities. Modern architecture is not a blueprint anymore, it is a philosophy, a compass for how agentic AI should behave, evolve, interact, and influence the world. These 10 principles are not guidelines, they are survival strategies because the future of agentic AI will be shaped not by how capable the agents are, but by how strong the architecture beneath them is.